Projection of solids in simple positions. In this video, we will discuss the projection of solids in simple positions. Let's see the projection of solid placed in different positions. Projection of solids in simple positions, we have three positions under it. Axis perpendicular to the HP, axis perpendicular to the VP, axis parallel to both the HP and the VP. Projection of solids with axis inclined to one of the reference planes and parallel to the other, we have two positions under it. Axis inclined to VP and parallel to HP, axis inclined to HP and parallel to VP. Projection of solids with axis inclined to both HP and VP. Let us discuss the projection of solids in simple positions. Axis perpendicular to HP, axis perpendicular to VP, axis parallel to both HP and VP. Before going to see the projections, first let us discuss some important points. The projection of a solid on the plane to which its axis is perpendicular will show the true shape and size of its base. Hence, when the axis is perpendicular to the ground, that is to HP, the top view should be drawn first and front view will be drawn from it. If the axis is perpendicular to the VP, beginning should be made with the front view. The top view should then be drawn from it. Axis perpendicular to the HP. Draw the orthographic projections of a pentagonal pyramid, base 30 mm edge and axis 50 mm long, having its base on the HP and an edge of the base parallel to the VP. Also draw its side view. Let us note down the given data first. Edge of the pyramid is equal to 30 mm, axis is equal to 50 mm, base on the HP, edge parallel to VP. Okay, first draw a reference line as the XY line, say 100 mm. The true shape of the object should be drawn first. It seems from the orientation that the top view projected on HP gives the true shape of the base. Let's draw the top view first. From the top view, it just looks like a plain pentagon. According to the problem, one edge of the base is parallel to VP. So let's draw the top view of the given object as a pentagon below the reference line, keeping one edge parallel to VP. Let's name it as A, B, C, D, E, as it is a top view. Mark the center as O and join it with A, B, C, D and E. Now draw the front view of the pentagon. Front view looks like this on VP. To get that shape, draw the construction lines from A, B, C, D, E up to reference line and name the intersection lines as A', B', C', D', E' accordingly. We know that the length of the apex is 50 mm. So mark a point 50 mm above the reference line and name it as O'. Now join A', B', C', D', E' with O'. The lines extended from A' and E' are invisible from the front view. So represent them with dotted lines. This is nothing but the front view. For the side view, draw an X1, Y1 reference line to the right of the front view and name the intersection point as Q. Now extend the lines from top view A, B, C, D, E and O horizontally towards the right until touching the X1, Y1 line. Now take a compass and measure the distance from Q to the first intersection point. With that distance, draw an arc from intersection point towards the XY line and repeat the same procedure for the other three intersection points. And mark the corresponding intersection points as E1, A1, B1. Now draw a vertical line from the nameless intersection point. From the front view, draw a construction line horizontally until it meets the vertical line and name the intersection point as O1. This vertical line is nothing but the apex line and we cannot see it from the side view, so make it a dotted line. Now join E1, A1, B1 points with O1. This is nothing but the side view. We can only see 3 lines from the side view because the edges ED and AC coincide watching from this view. We have seen how to draw the top view and front view and side view of a pentagonal pyramid with its axis perpendicular to HP. This is the procedure to represent the projection of a simple position of a solid. Projection of solid when the axis is perpendicular to VP. A hexagonal prism has one of its rectangular faces parallel to the HP. Its axis is perpendicular to the VP and 3.5 centimeters above the ground. Draw its projections when the nearer end is 2 centimeters in front of the VP, side of the base 2.5 centimeters long, axis 5 centimeter long. First, draw a reference XY line, let's say 100 mm. According to the problem, the axis is perpendicular to VP and one of the rectangular faces parallel to HP and 3.5 mm above HP. In this orientation, the base will be projected in true shape from the front view. So first, we will draw the front view. You can see that the front view looks like a regular plane hexagon. So draw the front view of the given problem as hexagonal with one of the faces parallel to XY line at a distance of 3.5 mm. Each side length should be 2.5 centimeters long as given in the problem. The hexagonal prism has 2 hexagonal faces, front face named with letters and a back face indicated with numbers. So let's name the front view of the hexagonal corners as A-1-, B-2-, C-3-, D-4-, Phi-E-, F-6- and name the centers as O-. This is how the front view is drawn on the drawing sheet. Now let's draw the top view. We can see that the top view looks like a rectangle. First, draw the construction lines downwards from the front view hexagonal corners and also from the center of the hexagon O'. As the object is 2 centimeters in front of VP, draw a horizontal line joining all the construction lines below the reference line at a distance of 3 centimeters. Name the intersection points as 1, 2, 6, 3, 5, 4 and the middle point as P. As the axis is 50 mm long, let's draw a 50 mm vertical line downwards from point P. This is the axis of the object. The rectangular edges also contain the same length as the axis. So draw the vertical downward lines from 1, 2, 3, 4 intersection points. Now join the bottom points of the vertical lines and name them as A, B, F, C, E, D and axis point as O. Make the axis line PO as a dotted line. This is how we draw the top view. We have seen how to draw the top view and front view of a hexagonal prism with its axis perpendicular to VP. Axis parallel to both HP and the VP. A triangular prism of base 40 mm and height 65 mm is resting on the HP with one of its rectangular faces lying on HP at a distance of 20 mm from VP. The axis is parallel to both VP and HP. Draw its projections. First, draw a reference line XY, let's say 100 mm. As the axis is parallel to both HP and VP, we can see the true length only from side view. So let's begin with the right side view. We can see that the side view looks like an equilateral triangle. So draw an equilateral triangle with 40 mm as side length touching the XY line. Mark the centroid on the axis line. For marking centroid, draw any 2 medians of the triangle. We can draw medians from vertex to midpoint of the opposite side of the triangle, like from vertex A1 to midpoint of side B1C1 and from vertex C1 to midpoint of A1B1. Now where these 2 medians will intersect will be the centroid of the triangle. Name the centroid as O1. Name the corners as A1D1, B1E1, C1F1 as the triangular prism has two faces. The true triangular faces of prism are A1, B1, C1 and D1, E1, F1. This is the right side view of the triangular prism. Now let's draw the front view. The front view of the triangular prism will be rectangular. To get the front view, draw the extension lines horizontally towards the right of the side view from the points B1, E1, A1, D1 and O1. Project the front view horizontally from this triangle. Give an axis 65 mm, so the length of the rectangle will be 65 mm and breadth can be obtained by extension lines from the side view. Name center axis as O', P' and vertex of rectangle as A', D', B', E', C', F'. Project down the top view from the front view and the side view. Extending construction lines from corners of the front view, we can obtain length by front view. To obtain breadth of top view, project the lines from the side view corners using a protractor as shown. We will get the top view and mark axis as OP and vertex as AC, D, F, B, E. The side, front and top view is the required projection of the problem. By considering these steps, we can draw the projections of our requirement. Projection of regular solids. We know that the solids may be placed in different positions with respect to HP and VP. Some of the important positions are as follows: axis perpendicular to the HP, axis perpendicular to the VP, axis parallel to both the HP and the VP, axis inclined to the VP and parallel to the HP, axis inclined to the HP and parallel to the VP, axis inclined to both HP and the VP. Fortunately, there is a standard procedure for all of these positions to draw the projection of solids. Let us see the standard procedure with which we are gonna work with the projection of solids. There are 3 steps we need to follow. Step 1. Assuming the initial position. Step 2. Inclination of axis. Step 3. Edge inclination. Assuming initial position. If the axis is inclined to HP, then assume the solid resting with its base on HP. In this case, its true shape of base is seen from top. So start drawing with top view. Same applies if one of the faces is resting on HP. We should consider it as standing on HP and start with the top view. If the axis is inclined to VP, then assume the solid rests with its base on VP. In this situation, its true shape of the base is seen from the front. So, start drawing with front view. Same applies if one of the faces is resting on VP. We should consider it as standing on VP and start with the front view. Keep that edge perpendicular to XY, which is inclined to either HP or VP. Axis inclination. After deciding the initial position and drawing the top and front views, we have to consider the axis inclination and modify the front and top views of step 1. Edge inclination. In the given problem, if the edge is inclined to either HP or VP, we should place that edge perpendicular to the XY line. Let's take a problem and draw the projections so that we can understand the procedure well. Problems can be solved either after step 1 or after step 2 or after step 3. So let's see the problem for all conditions. A cube of 50 mm long edge is resting on the HP. With its vertical face equally inclined to the VP, draw its projections. First, write down the given data in a drawing sheet. We need to mention only the given data in the drawing sheet. We need not write procedures of projection. Side of cube is equal to 50 mm. All sides of the cubes are equal. Long edge resting on HP. Vertical faces of the cube are inclined equally to VP. There are 4 vertical faces of the cube. So each face will be inclined to 180 divided by 4 is equal to 45 degrees with VP. Let's start with the initial position, step 1. It is given in question that vertical faces of the cube are inclined with VP, so the vertical faces of the cube are drawn below the XY line with 45 degrees. And the longer edge is resting on HP, so the longer edge should come perpendicular to the XY line. So we first start drawing the projection with the top view first. The top view of the cube will be square. It is given that vertical faces are inclined equally, that is, each vertical face will be inclined at 45 degrees with VP. So first draw a line using a protractor measuring 45 degrees with reference line XY. Now draw one side of the face ABCD, that is CD measuring 50 mm in 45 degree angle line. Draw the square ABCD top face and EFGH bottom face with each side 50 mm from line CD. The square ABCD and EFGH is the top view of the initial position. Now project the front view. The front view of the cube, which is also a square prism, is rectangular in shape. It is given longer edges that are E-A-, F-B-, G-C- and H-D- are resting on HP. So these should be drawn perpendicular to the XY, touching XY line, each measuring 50 mm. And we get the base of the rectangle from extending the construction lines from corners of the top view. The top view and front view are the projections of the cube as per the problem. Step 1 initial position gives the exact dimension of the cube. This is the required projection of the cube. This is the problem that can be projected in step 1 only.